All right, this is section 3.3, and we're going to talk about Chebyshev's theorem. And this is Chebyshev. He's a Russian mathematician, and you can see that he was one of the founding fathers of Russian mathematics, or modern day Russian mathematics, I'd say. And so he lived from 1821 to 1894, so about the turn of the 1900s. So yeah, you're talking about 100. Well, he was born almost 200 years ago. So he did a lot to really move the field of statistics forward. And so what we have here is something called Chebyshev's theorem. Now, this is actually a really deep theorem, and we're just going to sort of cover the surface of what the theorem says. And so what does Chebyshev's theorem say? It says, and what it does is it sort of puts two pieces together for us. It takes the mean and the standard deviation. And it says, okay, if you've got, let's say you've got a numerical distribution. So let's see if I can, well, you know what? I'm not even going to draw this. I'm going to show you this graph because my drawing will not be better than this graph. So let's say you've got this distribution, and that's the blue line, right? So you've got this distribution of data. Okay, and you can see that this distribution happens to have a mode right here, right? So this would be the mode, and you've got the mean that is sort of in the middle right here. There's the mean. And this is what Chebyshev's theorem says. It says if you take this data set and you calculate the mean, okay, you find a value for the mean, and you go and you find a value for the standard deviation. Okay, so I got a mean and I got a standard deviation. If you take that standard deviation and multiply it by 2 times the standard deviation, 2 times the standard deviation, and you add it to the mean, and then you take 2 times that standard deviation and you subtract it from the mean this way, that interval, these endpoints, the lower boundary and the upper boundary, the numbers that you get when you subtract 2 standard deviations from the mean, and the number that you get when you add 2 standard deviations to the mean, that interval, that boundary, you should expect at least 75% of the data points to be within that interval. Okay, so this does two things. It goes back to our old friends, the mean and the standard deviation, right? A measure of center and a measure of variance, okay? But it creates an interval, a lower bound and an upper boundary, between which we should expect to find 75% of our data points. This is an idea that we're going to visit again and again in this class, this idea of an interval. Now, this interval has a center point. That center point is the mean. And then from that center point, you add and subtract 2 standard deviations. And Chebyshev says, if you do that, you should get a 75% of the data. Now, what if you wanted to multiply your standard deviation by 3? So if you multiply your standard deviation by 3, Chebyshev says, so you take your mean, and once again, you multiply by 3 standard deviations, and you add that to the mean, and then you multiply by 3 standard deviations, and you subtract that from the mean. Chebyshev says you should expect 88.9% of your data to fall in that interval, a wider interval, right? 3 standard deviations above and below the mean. And then he goes on to say, if you go 4 standard deviations above and below the mean, you would expect 93.8. So this is 4 standard deviations above the mean and 4 standard deviations below the mean. So how can you apply this? So let's say that you find some data like this. This is the number of violent tornadoes in the United States, violent being categorized as above an F3 tornado, from the years 1954 to 2012. So the first thing we're going to do is we're going to throw this data into a spreadsheet. We're going to find the mean. We're going to find the standard deviation. Okay. And that's what we do here. So we copy and paste the data into a spreadsheet. Here's our mean and here's our standard deviation. Okay. Fantastic. Now what we want to do is find out what is 2 standard deviations above and below the mean. What is that interval? And so we ask that question. So here's our mean, here's our standard deviation, and here's the calculation. So we're going to take our mean and we're going to subtract 2 standard deviations. So this is our mean. and here is 2 times the standard deviation. And when you do the arithmetic, you will get an answer of about 1.88. That's the lower bound of your interval. So 1.88 is the lower bound of our interval. The upper bound is when we add 2 standard deviations, and that's 90.6. And again, don't forget, our mean is right in the middle, 46.24. And if you take the standard deviation, you multiply it by 2 and add it, this would be plus 2 standard deviations, and this would be minus 2 standard deviations. Okay, so this interval from 1.88 to 90.6 is the interval where we would expect to find 75% of these data points. So about 75% of these data points are within that interval. So at least 75% of the years would have between 2 and 91 tornadoes. We do the same thing to find 3 standard deviations above the mean, the 88.9% range. And when we do this, you find just one quick note, we end up with a negative number, and you can't have negative tornadoes. You can't have a negative. How many tornadoes last year? -5. That doesn't make any sense. So we're just going to round that to 0. Okay. And this again is a situation where the mathematics doesn't translate really well to the real world. And so even though we should say that there are -20 tornadoes, mathematically there's -20 tornadoes. In real life, we can't have -20 tornadoes. So we got to say 0. Okay. So just wanted to point that out. Finally, the last part of Chebyshev's theorem, and this is important. This is pretty interesting. This is an idea called commonality. And let me set this up for you. Okay. So let's say I'm going to add a little bit of space here off to the side. So let's say that we give an exam. Okay. And we give an exam, and the mean on the exam, let's say that the mean of this exam was, how about an 84? 84% was the mean. Okay. So that was the average test score, 84%. And let's say that we calculated the standard deviation to be, I don't know, how about 3? So 3 percentage points was the standard deviation. Okay. So if I wanted to find the 2 standard deviations above and below the mean, I would start with my 84, right? This is Chebyshev's theorem. So I'd start at 84, and I would go 1, 2 standard deviations above the mean, and 1, 2 standard deviations below the mean. Now the standard deviation is 3. This is 3. So 84 plus 6, this would be a 90%. And if I went 3 below the mean, that would be 81, 78%. Okay. So I could be assured that 75%, at least 75% of all the exam scores would be in this interval. Okay, great, fine. This is 1 standard deviation. This is 2 standard deviations. This would be -1 standard deviation. This would be -2 standard deviations. Okay. What if you take this test and you score an 88? An 88. How many standard deviations above the mean is your 88? Well, we know that 90% is 2 standard deviations. We know that 87 would be 1 standard deviation. So how many standard deviations above the mean is your score of an 88? To calculate this, we use 3 things: the mean, the value in question, and the standard deviation. This number is called commonality. Okay, commonality is this idea of saying, instead of using whole numbers like Chebyshev did, 2, 3, and 4, we may have to find decimal values that are above the mean. So here's what we're going to do. We're going to take your 88, that is your score right here, and we're going to subtract the mean, which was 84. And we're going to divide that by the standard deviation, which was 3. So if you take 88 minus 84, that's 4, and divide it by 3. So your value was 1 1/3, or 1.33 standard deviations above the mean. 1.33 standard deviations above the mean. This is called commonality. later on in this course, we are going to call this your z-score. I cannot call it the z-score just yet because there's some other things we need to build into it. So pretend I didn't say that. It's not a z-score, but really it is a z-score. We're going to call it a z-score in a little bit. But this is an extremely important calculation where you take the mean, or your value, I should say, the value in question, your target, you subtract the mean and you divide by the standard deviation. And that will give you something called commonality or a z-score, okay? And so what Chebyshev's theorem says is if your commonality is less than 2, then you have a common value. It's a familiar value. It's not that far away. But if your commonality is greater than 2, if you're more than 2 standard deviations above the mean, then this would be called an uncommon number. Okay. And the threshold is 2 standard deviations above and below the mean.